Welcome to another video from Learn Tech Easy on the subject Engineering Graphics. In this video, we are going to discuss development of a truncated cone. We can discuss it with a problem. Draw the development of a cone of base diameter 40 mm and axis height 60 mm, standing on the ground with its base. It is cut by a plane, 45 degrees inclined to HP, and the cutting plane passes through the midpoint of the axis of the cone. For drawing development of surfaces, initially we have to draw the projections of the part, or component, or solid. Here, cone is simply standing on the ground with its base, so that the axis of the cone is perpendicular to HP and parallel to VP. Then the sectional plane, 45 degrees inclined to HP, cuts the cone through the midpoint of the axis of the cone. When the section part is removed, the remaining part of the cone is called a truncated cone. When an object's axis is perpendicular to HP and parallel to VP, its base shape can be seen in the plan, and we have to draw the plan first. Draw the XY line. Draw a circle with radius 20 mm as the plan of the cone. Divide the circle into 8 equal parts. Name the points as 1, 2, 3, 4, 5, 6, 7, and 8. Name the center of the circle as O. This is the apex point of the cone. Project the center above the XY line. This is the axis of the cone in the elevation. Mark the height of the cone 60 mm. The end point of axis in the elevation is the apex point O dash. Project the base points of the cone up to the XY line. Name these base points of elevation as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and 8 dash. Connect the extreme left end point to the apex point, O dash. Connect the extreme right end also with the apex point. These are the generators of the cone, and should be dark. A cone does not have any slant edges or triangular faces around it. But we have to find out the points around the lateral surface of the cone, wherever the cutting plane cuts the cone. So join all other base corners also to the apex point with very light lines. These are the projections of the cone in the simple position. The cone is cut by a plane, 45 degrees inclined to HP, and the cutting plane passes through the midpoint of the axis of the cone. Mark the midpoint of axis. Draw a horizontal reference line or guideline. With the help of a protractor, draw a 45-degree line through the midpoint. This is the cutting plane line or sectional plane. Mark points on the divisional lines, wherever the cutting plane cuts the object. A dash on the 1-O dash line, B dash on the 2-O dash line, and so on. C dash, D dash, E dash, F dash, G dash, and H dash. Now, for drawing the development part, measure the true length of the generator. At a convenient place, mark the point O, and draw a line with length equal to that of the generator. Also draw an arc with the same distance as radius. Since a cone does not have any base edges, the included angle of the development is to be calculated using the formula radius of the cone divided by its true length of generator and multiplied by 360. Here the base radius of cone is 20 mm. True length of generator is 63.2 mm. 20 divided by 63.2 and multiplied by 360. We will get 114. So, the included angle is 114 degrees. Now, we have to divide the arc segment into the same number of parts as we have on the base of the cone. Here the included angle of development is 114 degrees. 114 divided by 8 is 14.25. 14.25 degrees is to be marked first. Measure this distance of this segment on the arc, and cut arcs to mark the remaining points. Draw lines from all these points to the center of arc point O. Name these points as 1, 2, 3, 4, 5, 6, 7, 8, and the last point is again 1. Now, for finding the true distances of all the intermediate points of the cone, project all the points of the cutting plane horizontally up to the generator. Measure each of these distances, and transfer it to the corresponding line of the development part. Measure the distance of A'. Mark it on line 1. On both the ends. Measure the distance of B' and H'. Mark it on line 2 and 8. Measure the distance of C' and G'. Mark it on line 3 and 7. Measure the distance of D' and F'. Mark it on line 4 and 6. Measure the distance of E'. Mark it on line 5. Join these points B, C, D, E, F, G, H, and with a smooth curve. Darken only the required part of development. By this we have drawn development for the given truncated cone.